Okay, now that we have all these definitions, let's get our visual. Okay, let's get our visual. So let's start with the central angle. Okay, the central angle in this diagram is angle AOB. We start at A, our vertex is O, the end of the angle is B. So the central angle is angle AOB. The corresponding chord, okay, so the chord, remember the definition of a chord, it connects 2 points on a circle. So that line right there from A to B is the chord. So I traced it in blue. That's our chord. The minor arc. Okay, the minor arc. So I'm going to use green for my minor arc. Here's how you kind of need to look at the minor arc. What I do is I extend the sides of my angle. Okay, I go outside the circle here so that I can see where it has cut this circle into 2 pieces. If I kind of, if I use those lines as scissors, essentially, okay, it cuts it into 2 pieces. So A to C to B, okay, when you see that notation, that arc ACB, you start at A, you go to C, and then you end up at B. That is the minor arc over here on the right side. Now, we could also name that. We could just name that arc AB. Since it's a minor arc, we can just use its endpoints. We don't have to include that point of C in there. And then the major arc is the remainder of the circumference. So it's from A to D to B. So that's how we name those major arcs. And that's how we identify them. Okay, so you start with the first letter, you go directly to the second letter, shortest distance from the first letter to the second letter, and then you end at the third letter. So if we put the major and the minor together, we end up with the entire circle there. Okay, we end up tracing the entire circumference of our circle. All right, any questions about central angle, minor arc, major arc? We go to that. All right, here's what we're going to do with these. The degree measure of a minor arc is equal to the measure of the corresponding central angle. Okay, the degree measure of a minor arc is equal to the measure of the corresponding central angle. So if I know that that central angle is 111 degrees, then the matching minor arc is also 111 degrees. Okay. The degree measure of a major arc is, what do you think goes in that blank? What do you think goes in that blank? We're talking about the it's the entire, well, we're talking about the entire circle. How many degrees, if we're talking about degrees? 360. Okay, there's 360 degrees in an entire circle. So if we know the minor arc, then 360 degrees minus the measure of the corresponding minor arc will give you the measure of the major arc. Okay, so let's apply this. Suppose that in the diagram to the right, the measure of angle AOB. I like to trace it. If they give me an angle or they give me an arc, I like to trace it on the picture. So from A to O to B, they say that that angle is 160 degrees. So that's 160 degrees right there. Okay, it doesn't make sense to put it on the other side because that's clearly more than 180 degrees on the other side. So it goes inside that angle right there. What is the measure of arc ACB? So I'm going to trace it. A to C to B. That is the arc that is intercepted by this angle. So the 160 degrees is the central angle that goes with this minor arc. So this minor arc is 160 degrees as well. The major arc, the rest of it, ADB, A to D to B, that major arc would be 200 degrees. Because if the minor arc's 160, I got 200 left to make up the entire circle. Okay, now C, on the diagram to the right, show possible locations of a point X so that the measure of arc AX is 90 degrees. So I want y'all to think about that for a second. See if you can come up with a possible location for a point X on the circle. Okay, X has got to go on the circle somewhere, and we want the arc from A to X to be 90 degrees. We got to start at point A, we got to end up at X, and it's got to give us 90 degrees. Think about that for a second. See if you see what you think. Put a point on your circle. There are actually two places where this point could be. X could be over here about halfway between C and B. Okay, and the reason why is if I put that line right there, that line forms a 90-degree angle with the radius OA. So if the central angle is 90 degrees, then the minor arc is also 90 degrees. So then X could also be over here close to D. Okay, both of these possibilities are what they're looking for. Okay, if X is over there close to D, or if X is about halfway between C and A, from A to X, that would be a minor arc that corresponds with a 90-degree central angle. Okay, let's fill in some more blanks. Two arcs have the same measure if and only if their central angles are congruent. That kind of makes sense. If the measure of the arc goes with the measure of the central angle, then obviously two arcs can only be equal to each other or have the same measure if their central angles do too. Kind of one of those duh things. The measure of two minor arcs are equal if and only if the lengths of their corresponding chords are equal. Now, we won't use this one as much, but you never know. But that also makes sense. If the chord has the same length, then that central angle is going to have the same length. So those minor arcs are going to be equal to each other. Okay? So if the chord is the same length, that central angle is going to be the same measure. So the minor arcs are going to be congruent to each other. All right, so here's what we're